Welcome again as the engineers try to tackle these situations. Today's situation number 2. Well, it says motor A must start before motor B when both motors are running and when motor A is stopped. Motor A cannot be started again until motor B is stopped. The emergency stop must stop both motors and the overloads must protect them. Well, as you can see, this on the circuit diagram, we are using 220 volt conductors. Why am I saying that? Because we use line 1 and the neutral. Well, we have the emergency stop button. Let's take a look at the first section here, this circuit for motor A. We have the overload for motor A, we have to protect motor A only. And the stop button, from the stop button we have the start and this holding, and then we go down to the normal open of motor A, the auxiliary of normal open of motor A, and the auxiliary of motor B, normally closed. Then finally to A1 of motor A, the conductor, and then the return part, which is the neutral. Then we go to the other circuit for motor B. Start with from the emergency stop, we go to the overload. From the overload we go to stop. From stop button we go to start button with its normally open holding. Then we go to the normal open auxiliary of conductor A and normal open of conductor B. Then we go to the A1 of the conductor of the motor B. Then the return part, neutral. Well, today I'm going to take you step by step in wiring this circuit. Right, first of all, we will need to know how many conductors do we need. How many conductors do we need? How many components, all in all, how many components do we need? Right, we need one stop button, emergency stop, and another stop and another stop, which makes it 3 stop buttons. We need to have 2 overloads, thermal overloads. We should know their ratings, how many amperage when connecting these motors, these directing line motors, and also need to know the correct measure amperage of your direct line of your overloads. Like this one, the maximum is 8 amps. The maximum amperage for this overload is 8 amps. There are different types, different kinds and sizes of these overloads. Well, we go to, I mentioned the stop button, I said we need 3, so the overload we need 2. Now we come to the start buttons. How many do we need? 1, 2. We need 2 start buttons. Then here we have auxiliaries. So we need for the conductor A, we need how many auxiliaries? We need 1 stop, 1 normal open auxiliary, and the other normal open auxiliary. So we need 2 normal open auxiliaries. No, this one, the bottom one. This one is the whole thing.
Oh, okay, yeah, for A.
Yeah, I'm on the auxiliaries part. So on conductor A, we need 2 auxiliaries, normal open. And then for conductor B, how many auxiliaries do we need? We need the normally closed for B, 1. And then we need another normally open for B. So we need normally closed and normal open. 2 auxiliaries, normally open and normally closed. Then how many conductors do we need? We need 2 because it's 2 different motors. Well, here are the contacts. Right, since the wiring is 220 volts because we have neutral. I'm using 220 volts. This is a 220 volts conductor, as you can see.
I hope it's clear enough.
And the other one is 220. Since I mentioned we need 2 conductors, right? They are the 2 conductors. And then we go to the auxiliaries. How many auxiliaries do we need? Since we have these 4 points auxiliaries, normally closed and 2 normally opens, where they are clipped directly on top of the conductor. Then we clip this one again here. Right. So now we have a conductor with an auxiliary, a conductor with an auxiliary. Now we're done with auxiliaries. We're going to the start buttons. How many do we need? We say 2. Well, if it's 2, here we have 2 start buttons. 1, 2. These green ones. 1, 2. These are our start buttons. Then we go to our stop buttons. So how many do we need? 1, 2, 3. We need 3 stop buttons. 1, 2, 3. This one is the stop button. It will act as an emergency stop button. And the overload, how many do we need? 2. We need this one, 1, and we have the other type, second one. Okay, for this purpose of demonstration, we won't wire the power circuit, but we wire the control circuit only. Right, before we begin anything, one has to test his or her components, whether all the poles are working correctly, the poles of the auxiliaries are working correctly, line 1, line 2, line 3 is working correctly, 13, 14 is working correctly, even A1 and A2, are they sound or not? If it's not sound, it will make some grrr sounds when you power out this power on the circuit. We'll need to see whether your start buttons are the normally open or normally. See the stop button, whether it's normally open or it's normally closed. Well, for our start button, it should be normally open. So you have to test whether it's normally open. And our stop button, it should be normally closed. So you have to test whether is it normally closed or it's normally open. Well, you are using a Mustech meter. You have to take your meter. You have to put this aside. Right. Once you have your meter, you put it on ohms range. Now I want to test whether
it's a bit dark.
It's a bit dark. Alright, well, let's put it like this.
Yeah.
Okay, now we want to test every component that we will use. And also, I forgot about the breaker. We need a breaker for the control circuit, which is this one. You are using a 3 amp breaker for the control circuit. Well, before you test anything, you have to test your leads, whether you put on the right function. Right, you test the leads. Right, it's working well. 0. Now we have to test each and every component step by step. We go to, first of all, you have to test the breaker, where the power is coming in. One lead on the other side, one lead on the other side. The breaker is not on, it's on off position. Right, it's open. If I push it up, this is the normal, this to be on. So I'm expecting to find a reading here. Here is the reading. Thank you. So the breaker is working well. Anyway, now we go to which other component shall we go to next? The one which we say we are going to act as a normally closed, which will be our emergency stop button. It's red. So here you have to find the red part. Is press it on. Is this 1 and 2 points? It's normally closed. So I want to test whether it functions or it does the opposite. So first of all, before I press it, it's written normally closed. So if I test for continuity this side, I should have continuity. There I have continuity 0. Let me remove one lead and see whether it's not lying. And put it back. Yes, it's working well. So if I press it here, it should open up this side. It's open. I release. I press once again to make sure. Right. So this emergency stop button is working very well. Well, now I go to the first overload. First overload has got 2, for the controller it has got 2 points, the normal open and the normal closed. But I want the non-closed points. So I have to test which points are the normally closed, which are the normally open. Well, I come here, it's normally open. Then I go to the other side, it's normally closed. Let me just try and test the other side, the other points. Nothing. How do I know whether these are the points? It's written normal open, normally closed, 98, 97, 96, 95. So you have to go where they are saying normally closed and test whether it's closed. If it's not closed, to test the other ones. Maybe it's the normal close is on the left side or on the right side. If all are open, which means if all are open and somewhere is written normal closed and the normal closed part is open, which means the overload is 40, you have to change it. So our overload is okay. Let's test for this side. Well, this is a different type of overload, but the principle is the same. So this is line 1, line 2, line 3. Hello. Video man. Projector.
Sorry for that delay. Was just busy helping someone quickly, so we are back.
Now I'm back. Well, this is line 1, line 2, line 3. How did I see that this is line 1? Let me just confirm whether this is line 1. There should be continuity. Let me first of all test again my leads. Alright, line 1, which means that's line 1. Line 2, something, yes. Line 3, something, yes. Right, now I need those normal closed and normal open points. How do I see? Now this is the way these things on each and every top of this contact. So now we have only one left, so you have to figure out which are the normal open, which are the normal closed. Since here is written 97 normally open, let me test this from here and here. There is nothing. And if I test from here and here, there's nothing. Let me again test my leads. Let me test from here and here. There's nothing. From here and here, there's nothing. Test once again. Nothing.
Your hands. Alright.
Well, but it was working very fine. Right, that's it. Now it's working. I think it's because these contacts are now losing up. Right now, I wasn't pressing hard, wasn't making any contact there. So I found out that this is the normally closed. Well, I may as well go back and confirm this one is normally open. Right, so I go back here. Right, this is normally closed.
And so, OL means open loop.
Yeah. So now I know 3 or 4 of my components are working well. Now go to my start buttons. Well, these start buttons, start and stop buttons are connected to this terminal block. So now I have to determine which is the start button, which is the stop button, which is the other start, which is the other stop button in this block terminal. How do I do that? I test once again. Right, before I test my leads. Are they still on ohms function? Right, first of all I need to test.
Just bring it closer.
Right, so I have to test this side only because the cables are coming into this side, so I'm testing this other side. If I put my leads here, it's written something. If I go next, there's nothing. If I go next, nothing. Next, there's something. Right, so I found out that there's 2 points closed, 2 points closed. At the center is 2 points open, 2 points open. Well, now I need to determine which is which on this terminal block. Go back on the first point and something. I press the stop button. Is it opening? No. I press this one. Right, yes. So I determined that this first point is the stop button. Well, I go to the second point. It's normal open, which means it's the start button. After this, I need to determine which is which on this tray. Right, I press this one. There's nothing. It's not closing up. I press this one. It's closing. For confirmation's sake, I'll repeat the process. Nothing. Something. So I've determined that this is the start button. these points, these 2 points. Then I continue my testing. Normal open. When I close the start button, it should close. Now I know this is the only start button left, so I press it in. It's closed. I press this other one just to make sure there is no continuity sake. I press again this one. Well, that's it. Confirmed. I go to another stop button. When I know this one is on left, I press stop. It should open the circuit, right? I press it again to make sure, right? I press this one just to make sure there is no continuity there, nothing. I go back and then test again. Yes. So I've determined that the first points are this stop button, the other two are the start button, the other two the start button, the end is the stop button. Well, now I go to the conductors. Well, as already plugged in the auxiliaries. First of all, I need to test the auxiliaries, the normal closed and the normal open. Well, I come here, test the leads once again. I come here. It's not written whether it's normally closed or it's normal open. Yes. Whether it's written or it's not written, you have to confirm with a meter. Right, it's open. I remove the leads, I put them back just to make sure it's open. Yes, it's normal open. I come here, the second point, it's closed. Right, it's closed. I remove the leads, I put them back to make sure normally closed. So if normally closed and normal open, I go to the third point, third contact, it's normally closed. I remove the leads, I put them back to confirm normally closed. Right, go to the last one, open, I remove, I put them back to make sure normally closed. I repeat the same process just to confirm everything. Here normal open, here normally closed, here normally closed, here normally open. Right, so I've tested that this auxiliary is working well. Right, first of all, I need to test if A1 and A2 are sound, whether I test from here and here or from here A1 to this A2. Let me first test this one, A1, A2 and A1. Yes, it's sound. It's giving a reading. I remove, I put it back. It's giving a reading, which is good. I come here, test this one.
Which
this
point?
One is still A1 and A2. There is a reading. I remove. There is a reading. Wow, this looks like the coil of the conductor is in good condition. Well, now I want to test each and every pole. Line 1, line 2, line 3, and 13 and 14 points. Well, I need someone to help me punch this in, mechanically energize this in. Thank you. Right, I need to test now the poles, each and every poles. But before we energize, we want to test whether this pole should be open. Right, we go to line 1 and line 1. On the other side, it's open. I test my leads. Okay, I go back. It's open. I go to line 2 and it's open. I go to line 3. It's open. I go to 13 and 14. It's open. I repeat the same process again. Wow, it's open. Now we need to see if A1 is and A2 are energized, if this conductor, the poles are working, whether they will close or not close. If one pole is not closing, which means the conductor is will not be on good condition. If you are wiring a 3-phase, you won't be able to. The motor one will single phase. So we have to do out with that conductor and find another one which is on good condition. All the poles are working fine. So now my brother is pressed in. I show it's in. Test the leads once again. Line 1, there is something, which means it's closing. It's okay. Line 2, it's closing. It's okay. Line 3, it's closing, and then 1314 should close also. It's closing. Right, there we go. This conductor is working well. Now we're testing the second conductor. First of all, let's test the A1 and A2. A1 and A2. There's something. Yes, it's sound. Thank you. And then A1 and A2 of this side. There's something. Thank you.
Do it again.
Okay. A1 and A2. Right. Now the meter is complaining. Okay, well, let's proceed and test first the normally. This is the auxiliary. It has got 4 points: 2 normally closed, 2 normally opened. It's written even here: normal open, normally closed, normal closed, normal open. But I want to confirm whether it does what it says. Test the lead first. Right, now I'm testing the first one. It's open. I go to the second one. It's closed. I go to the third one. It's closed. I go to the fourth one. It's open. I repeat the process to make sure. Open, closed, or closed, open. Wow. Right, I'll need your help to punch this into. No, right. First of all, you have to test whether the poles are open before we test whether they can close. Right. Test my lead once again. Wow, the meter is stopped. Put it back on ohms, right? Test whether these poles are normal open. Right. Test again my lead. Right. We go back there. Line 1, line 2, line 3, 13, 14. I repeat the process. Line 2, line 3, line 4. Right, so I need your help to push this in, and to really push it in. Yes, thank you. So I need to see whether they closed or not closed. So I need to have a continuity here from here. Yes, I have. From this side, what about this side? Line 2, wait, let's go back and test again. There is contact. Line 3, is there contact? There is contact. Let's test once again. There is contact. And then 13, 14. There is contact. Right, thank you. Now we've made sure all our contacts are working well, all our components are working well. Then this is the tin rail where I can mount my conductors, put my conductors here. Right, now I'm following the circuit from the start. This is overload 1, overload 2, emergency stop. So from the line we need to go to the breaker. Power comes to the breaker, and then from the breaker I need to go to stop button, emergency stop button, which is this one. This is just for teaching purposes.
And under no condition should you try this at all.
Yes, without a skilled someone next to you, very dangerous.
Or a qualified electrician.
Now on point number 1 and 2. You need to put on point number 1. Make sure my cable is neat. There are no strands which should be left outside. Right, then we need a cable from point number 2 of the normally closed stop button. Right, so this is our emergency stop button, from the breaker to our emergency stop button. Then it come to, let's deal with this circuit first, this line first. we need to go to the overload top part and overload second overload top part. Right, since we tested, these are our normally close points, and then these are our normally close points. Right, so we come here, we put the cable, make sure your strands are neatly tight. You put the cable here, so I need the other one from here. I have to go to that side. So let me look for another cable. Right, so I'll put both of them here. I'll loop them here since it's the same point. Put this one here and then the other one on this side. And I make sure tight connections are there are tight connections. Then I'll go to my overload. Let me first secure my overload on this conductor, the second conductor. First of all, I need to make sure I open up these contacts very wide so that I can be able to put the overload nicely. Then I should tighten this here. Make sure it's very tight. Second pull, third pull. Right, very tight. Good. Right, so I need to go to the normally closed first point of the second overload. Put this cable in and I secure it there. Tight connections. Well, right, so I need to go to. Now I'm done with the first part. I'm now focusing on this circuit, the first circuit on motor A. So I need to finish up until neutral. Well, the overload, I'm here. I'm now at the bottom of the overload. This overload, which is this contact, from there I need to go to stop. So we'll use the stop and start button for the first motor, the stop and start button for the second motor. Right, so now I'm connecting. Find a good cable, not too long one, but just not too short, not too long. I need to open up here. And then I put it in and I secure, make sure there is a tight connection on this one. Right, therefore from there we need to come to this point. Open this terminal. Tight connection. Right, I'm now at the top part of stop button. Now I need to go from stop to start on the top part of start. This one I just need a loop, just a small thing. This one will do. Says this is top. This is top part of stop, bottom. This is top part of start, bottom. So I just need to loop the bottom part of stop with the top part of start, which is what I'm doing right now. Make sure it's open and it's tight. Now I'm securing the cable. Secure it clearly. Right, now the cable is secured. I'm now at the top part of the start. I need to go to holding of this conductor of motor A, which is this one, 13. I need to go from the start top part, go to 13. So I need a longer cable. Right, put it in, then secure it here, ensure it's tight. Right, then I'll have to put this cable there. And 13, make sure it's open enough for me to put this cable. Right, then I secure it. So there, this cable is secured. And now it starts. Now going to the start part, the start bottom part, and loop it with 14. This one. Okay, so I come here. So it's tight enough. Then I go to 14. Right, when I go to 14, I need a cable from 14 which goes to normally open auxiliary of conductor A. The normal open at the same time go to normally closed of B, the auxiliary. So if I come here from 14, make this cable sound, put it in. After put it in, when I close, when I try for a bit, I make a cable that comes from here, that will go to the top. Right, so let me open a bit here, and then put this one here. Now I can properly secure my cables, these two cables, right? There, make sure it's tight connections. Then I go to normal open, this top part and that top part, normal open of the auxiliary contact A. Now open up here, this is the top part. I need the cable, so I have to go to the closed, normally closed contact of B. I put it in this one. I have to put this one into. There, it's in. Then I secure it up. Right, when it's secured, I need to go to normally closed contact of B, which is this one. Secure it tight enough. Now I need to go. Right now I need to come from this point, then look here again.
I'm sorry if it's not loud enough because it's busy raining heavily, so
it's raining this side. Right, so I need the cable to go to A1. And now here, now going on now proceeding to type connections. Now I'm going to A1. It is usually, which is always the left side of the conductor when you're holding it right. Now I'm done with this whole part. I'm here. I'll connect the neutrals lastly. Now I'm going to this normally close point of the overload, then go to start to stop first. Sorry, go to stop first. Then from overload to stop here. From this point, overload to stop this point first. Make sure it's tight, and then I'll need just a loop my cable. And then I'll just need a loop. Open up this. Then I close here. Then I need the line from this start to 13 to the wording. So it's this one. Put it in first. Secure it here tight. I need to go to 13. Right, there we are, secured. Now I need the normal with the bottom part of the start button. I need to come here on 14. So maybe this one, this point. I need to go to I'm here now. I need to go to 14 and then same time go to normally open the top part of normal open auxiliary of A and the normal open auxiliary of B. So what I will do here is first of all connect my 14 on the conductor. Then I need a cable from there which goes to the auxiliaries. Then now securing the cables. It wasn't secured, so open it again and try and put it in. See if it will say it will be secure this time. Not again. Let me see what's wrong here. Open it there. secure it. Right, this time I managed to win. Then I need to go to normally open of the auxiliary, this one. Need to put the cable here. I'm here now. I need to connect the normal open of A. Need to connect the normally on this point, which is this point. Now I need to care for a jumper that's going from this point to the normal open of conductor A. This line, I need to connect this line again. I'm looking for a small cable. Right, set it here. Now it's okay. Now I'll put this one here and secure this one. Right. Secure this one here. Properly secured. See, it's not properly secured. Let me check. Got the right done. Right. This is it. Now it's okay. Tight connections are to be ensured. Right, I go to normally open the top part, which is this one. Right, now I'm done with these two parts. I'm going to the bottom part, which is connect here. Let me first connect on this side. Put the cable in and tightly secure. Right. Then I need to put the cable there, and then I want that to go to A1. Open up this contact. After opening this contact, you need to put these two cables in. This cable in, and this one in. Now we need to secure these two. Tightly secured. Tightly secured. Then I can go to A1. Open up A1. And connect A1. Then properly secure it with cable. Make sure it's tight. If it's not tight, the conductor will make grrr sounds. Right. I'm done up till this point. Until this point, now I need to connect the neutrals, which should be connected to the neutral. Now I'm connecting the neutrals here. Well, I'll connect on this side, the A2s. Connect the A2s. And then I'll take my neutral. This is my neutral. Black is my neutral. This one. So it's already connected on this. Then I come here, loop it up. Open up first. Just First of all, open it up, then put this one in and this one in, then tightly secure the cables. Make sure it's tight. Right, I've connected everything. The last thing, before energizing the circuit, I need to test everything, whether I made proper connections or I skipped some of the connections, or maybe I thought I put on the normal closed instead of the normal open. If I use the right things, right, I put them ohms. Right, first of all, from the breaker to the normal, to the emergency stop, to the stop button, I should be able to get continuity. First of all, test my leads, they are working well. Right, we go to the bottom part of the breaker. From there, I need to go to the bottom part of the breaker. I need to go to my stop, check my stop where the cable terminates and where it's coming. So when it's coming out, it's okay. My emergency stop, I connect it on the correct terminals. Then from there, I need to go to these points, the top part of the overload. I come here, I test if there is a reading, and right from here there is a reading, and then I go here, there should be a reading. Thank you. Now I focus on this first circuit A, I'll call it A. From overload, the top part of overload, because it's closed, I need to pass through the stop till the top part of A and 13 points. All these things should give me a reading. So I say this first two is my stop for motor A. Right, I come here, they should give me a reading. Thank you. Output of stop. Thank you. Then I go to start, the third point here. Thank you. Then I need to go to 13. There is something, yes. Right, after 13, I'm here. After 13, I need to go to 14. From 14, I need to go to normal open auxiliary of A and the normal close of auxiliary B. All these points should give me a reading. From the bottom part of A of the start button, I need to go to 14 first. There is something. It's reading. Thank you. I'll check again. It's reading. From there, I need to go to the normal open of A. Thank you. It's reading. The normally closed of B. It's reading. Thank you. Right, so I need from the bottom part, there should be something. Yes, there's something. Then I need to go to
Do that again.
which one?
No,
Which one
just to
should I
repeat it. The same one.
This one.
Ah.
Alright, this is the bottom part which I'm repeating. There's something. Then I go to A1. Should give me a rating. Yes, there's a rating. So my circuit is properly wired. And I'll just confirm if it's normally open. Then we put it on buzzer because there is a cable now. It will read, because this comes through normally closed of this one, so there is a reading. Then put a buzzer here. Let me check if it's normally open. Now it buzzing because there's continuity of this cable. Anyway, we tested before, it's okay. Right, so now we're going to where? Going to the circuit number B. We need to go from the top part of the overload. I need to pass through stop button till I get to this point where there's nothing here is open on top part of start button and number 13 of the conductor. I need to come here, there's something. Output of stop, there's something. Start top part, there's something. I need to go to 13. There has to be something. Thank you. There's something. I connected the circuit well. Right, from there I need to go to 14. The second part of the stop, the bottom part of the stop, I need to go to 14. From 14 I need to get normal open of this point, normal open of conductor A, of the auxiliary of conductor A. I need to go to normal open of the auxiliary of conductor B. Right, so first of all, auxiliary, I need to go to 14. 14 is, does it pass? Yes. From there I need to go to normal open conductor of conductor A, which is this one. Thank you. From there I need to go to normal open of conductor B. Thank you. From this one I need to go to A1 of conductor B. This A1. Why is it not reading? Alright, I was at the top. Yes, I was at the top. Sorry, should not read because it's open here. Now I come to the bottoms. Bottoms and 14. Right. Bottom 14. It comes here. Then it comes here. Right, so I need to go to the bottoms here, normal open. Well, this loop is okay. Therefore I need to go to A1. Thank you for that. Now I need to confirm whether this one is open. Let me check. If I come here from 14 and A1, okay, it's okay because there's no man closed here.
Which one?
There's no 14 of conductor A and A1 because there's no man closed here. It should give me something. But if I come here on 14 and A1 of the second conductor, there should be nothing because here it's open. So now I need to test my neutral whether it's sound. Test my neutrals. It's okay.
Wait. You just position the meter.
Alright. Test the neutrals. See whether the neutrals are sound. Yes, there is something. Go to the neutral there. Yes, there is something. Well, from the look of things, we did everything accordingly. Now we want to juice up. Everything is off. The breaker is on off position. Stop. Everything is good. Remove some of the stuff. Alright, so let me go and switch on the triple pole breaker and come here.
Alright, while he's going to switch on, we just make sure that all the wirings are correct, they're at the right points, and to avoid all the short circuits. So seeing that all our connections are in the right places and everything is fine, so we are now about to.
Okay, I'm back. Before I energize, let's just read again the question. It says motor A must start before motor B when both motors are running, and when A is stopped, motor A cannot be started again until motor B is stopped. Imagine stop must stop both motors, and the overloads must protect them, which means I can start A needs to come first, B needs to follow. But if I stop A, if I stop A while B is running, B cannot be A cannot be started again until I stop B. Let's see whether I need to do what it says. First of all, switch on the breaker. Right, we need to start A for B to start. A is in. Okay, this is A, it's in, it's running. Now I need to energize B. B is also on, now it's running. It says when both motors are running and when motor A is stopped, motor A cannot be started again until motor B is stopped. So let's stop motor A. We stopped motor A. It says motor A cannot be started again unless B is stopped. Let's try to start motor A. I'm starting motor A. It's not starting. It's not starting until motor B is stopped. Yes. So I can start motor A. Then I start motor B. Well, the first part was saying motor A must start before B. Right now I want to see, I'm stopping both motors. Now I want to see whether motor B will not start unless motor A is running. Let me try to start motor B. Starting motor B, nothing is happening. Unless I start motor A, then I can start motor B. Let's test whether our emergency stop is working very well. It stops all the motors. So start motor A, and then motor B will run. I can stop motor B and restart motor B. I can stop motor A but cannot restart motor B unless I stop motor B and restart motor A. Right, this is the end of our presentation. Thank you.
Thank you very much for watching, and if you do enjoyed our video, you can subscribe on our channel, and any questions, anything you like to ask or say, feel free to do that. We'll be happy to give you a feedback, and since that we are normally 3 on this project that we normally demonstrate, so any one of us can respond to any of your comments. So thank you, and see you again, and stay tuned for more videos to come, simple and complicated ones.